profiler, understanding customer segmentation in online retail. So this is a unsupervised type of uh, problem, and my problem description is: in this project, the objective is to identify major customer segments in a transactional dataset from a UK based and registered non-stored online retail company. The dataset encompasses all the transactions that took place between 1/12/2010 and 9/12/2011. The company specializes in selling unique all occasion gifts, and it caters to a diverse customer base, including wholesalers. So, the project requires an employing unsupervised machine learning techniques to cluster customers based on their transactional data, such as purchase frequency, total spend, item preference, and possibly other variables. So the ultimate goal is to provide the online retail company with a actionable insight and recommendation on how to effectively engage with and meet the unique requirements of each identified customer segment, thereby driving customer satisfaction, loyalty, and overall business growth. So this is my data description, invoice number, which is invoice number nominal a 6 digit integral number uniquely assigned to each transaction. If this code starts with letter C, it indicates a cancellation. So the second is a stock code, which is product item code nominal a 5 digit integral number uniquely assigned to each distinct product. So next is description, which is product item name nominal, and other is quality, which uh, tells the quantities of each product item per, per transaction numeric. This is like invoice date and time numeric, the day and time which each transaction was generated. And next is unit price, which is unit price numeric, product price unit in sterling. So before we start doing building models, so we have to understand our data description, because it gives better understanding of what we have in our data set, so we can better take the variables for our model. So I have imported the some important like libraries like NumPy, Panda, Seaborn, and next I have imported my dataset. So here, firstly, I have to like checking bottom five rows of data. Like firstly, I have to do EDA and checking data is there is any null value or what. If there is null value, then we will have to remove it and correct it for not our model will get interrupted by that null values. So this is shape of our dataset, this is rows and this is our columns. And info df.info, it is showing that where is df.info. mm, yeah, so df.info showing the invoice number, there is no null in our dataset. So next, here we can see that we have almost null values, no null values in customer ID, and all other columns looks fine. We can drop that null values in customer ID column, as we are making customer segmentation, and keeping those null values make no sense. So div.colon, I have removed it here. So next I have I have done data cleaning, like checking null values. So this is our null values I have checked here. So here we have null values present in our dataset, like in customer ID and description. We can drop that null values in customer ID column, as we are making customer segmentation, and keeping those null values make no sense. So we have to drop these null values here. So I have used is null df function from Panda to remove it. And next I have checked it again to get sure if there is other null values available in our dataset. and it is okay right now. So after removing null value from our data set, we have 4 lakh 6,829 rows and 8 columns in our data set. So I have here also changed the data type, which is so essential for our model building. So invoice is called df dot in invoice dot number age type a string. I have changed it to a string. So here we drop some invoice number which start with C, because C indicates a cancellation. So df.save, here we can set that this is our row and this is our column, and this is our summary. This is quantity number and unit price and customer ID. So next is I have done exploratory data analysis, which is EDA. In EDA, it is description name. Here we can see that, and what I have got through this graph, like top 5 product name. So this is our top 5 product name, which is white hanging hair light holder, jumbo bag red, retro sport, regency cake stand 3 tire, party bunting, lunch bag red, retro spare. So we can see here that the biggest product is white hanging hut lightning holder. By idea I have observed that. So description underscore df dot tells that this is count and this is the total count here. So bottom 5 product are ruby cluster earnings, pink Christmas art flower 72k case, vintage Christmas wallet, the magic forest paper swap. So next is a stock code name, which is value dot count research dot index, and this is our top 5 stock node name. uh, like uh, Here we can say that 22423, this is our stock ID, and we can say that here maximum 2000 are order here, and top 5 stock name based on selling are 85123A and 22423 and 85099B. So this is our top 5 based on selling. So in EDA have also, here we can say that it's a positively skewed or rightly skewed distribution. It is a type of distribution in which most values are clustered around the left tail of the distribution, transforming a skewed distribution to symmetrical distribution. Plot of figure. This is our uh, C1 code for visualizing data, and by this we get density, like it is rising fast and it is falling continuously, and then again getting boost, and it is slowed down here like 4 to 5, 4 to 6, it has slowed down. So distribution of unit price is here. And next what I have observed that from the distribution of unit price we can say that most items have a lower price range. Yeah, it was not so costly here. And next I have done feature engineering. Here we can say that converting invoice date column into date time format, and df invoice is called pd.to underscore date time df.invoice date format. This is our format. So creating a new feature total amount from product of quality and unit price. So here is the total amount and quantity and unit price. So this is the description of our data set, like what hanging hut, tea light holder like 6, white metal lantern, cream copied hearts coat hanger, knitted union flag hot water bottle, red holy hottie white heart. So this is, and like unit price is 2.553, and this is our customer ID, and this is the location of the country and month. All of these order from the month of December. So distribution of total amount, here we can see that total amount was distributed, and it was like 0.0030. We can see here that, and here I have plotted the month basis. So like here November month has most count like 60,000, and it was getting slowed down to February. So it was so high peak in November to like September, and then it gets slowed down to January, till January. So most numbers of customers have purchased the gift in the month of November and October and December. As we all know, they have festive season in end of the year is New Year to celebrate. So we have highest number of transaction in November, October and December. As company have most of the customer wholesales who are keeping stocks for festive season, and least number of purchasing are in the month of April and February. So I have used here time series data set. So like daytime is equal to Thursday, and it was the highest count like 80,000 in a one day. And here we can also that Wednesday has 68,000 count and Tuesday has 66,000 count. So day wise transaction was highly ordered in Thursday. We can say that approx it was ordered like uh, 80,000 in one day, and Thursday to Wednesday it was on high peak, and then later it was getting slower. So we can see the maximum number of transactions are for Thursday, but we can also see there are no transaction on Saturday. At this point, I have no idea why, but there can be a reasons. Probably data is not available for Saturdays, or no transaction happened on Saturday. Most of the customer have purchased the item in Thursday, Wednesday, and Tuesday. So I have observed here also in hour base, from the graph we can see that in this time zone it was ordered in like most of the time, and this time was between 12 p.m. clock to 3 p.m. And next, by this graph we can see that time wise transaction, uh, which which time zone has most of the transaction. Like here we can see that. So next, I have what have I done is create the RPM model, recency, frequency, monetary value. So RPM is a method used for analyzing customer value. It is commonly used in database marketing and direct marketing, and has received particular attention in retail and professional services industries. So, recency. How recently did the customer purchase? Frequency. How often do they purchase? Monetary. How do they spend in money? So here we can. I have three variable I have used, and from this graph I can see that recency, which is recently they how they use. So this density is about high density is about 0.08, and next is uh, monetary. So it is almost 0.0150. From all the graphs of recency, frequency, and monetary, we can say that are all positively skewed distribution. So splitting into four segments using quantiles. So I have used quantile like 0.25, 0.5, and 0.75. And what we can get through this is that recency is 3 to 5, frequency is 1, and monetary is 77,183. And next part is select a score method. So what is this method is this method is used to evaluate the quality of cluster created using clustering algorithms such as k-means in terms of how well samples are clustered with other samples that are similar to each other. So the Celestia score is calculated for each sample of different clusters. So applying Celestia score method of recency and monetary, what we can get here, that is so important for our model. Like this is what we can see here. So after this, in this graph we can see that here we can see that customer are well separated when we cluster them by recency and monetary. So this helps us in deciding for our model building and applying Celestia score method recency. So elbow method is one of the most famous method by which you can select the right value of k and boost your model performance. We also perform the hyperparameter tuning to choose the best value of k. It is an empirical method to find out the best value of k. It picks up the range of values and takes the best among them. It calculates the sum of the square of the points and calculates the average distance. So here we can also see that number of cluster k is like from 80,000 it was decreasing almost to 42 in between 4,000 to 500, and it was slowed down to like 1,000 to 2,000. So here we can also see that the customer are well separated when we cluster them recency and DB scan clustering. DB scan stands for density based particle clustering for application with noise. DB scan is a density based clustering algorithm that works on the assumption that cluster are dense regions in a space separated by regions of lower density. It groups densely grouped into a singular cluster. So here we can see that. So let's select the analysis of k-means cluster and sample data with n cluster is equal to 4. So this is our 4 clustering and it was showing good here. And from the selection it is clearly understood that two clusters are performing best, hence two cluster will be selected to build the k-means model and classify the customer. And applying elbow method, recency, frequency and monetary. I also have used here hierarchical clustering, is an unsupervised clustering algorithm which involves creating clusters that have predominant ordering from top to bottom. So for this I have used a dendro type of tree diagram showing hierarchical relationship between different sets of data. So using the dendrogram to find the optimal number of clusters, I have import scipy.cluster.hierarchy as such. This is the code for importing it, and next we can here see that uh, number of cluster is equal to 2 here, and let's check mean values for the cluster of recency, frequency and monetary. So this is our mean value like 140, 24, 469. We can I can see from above that the customer belongs to cluster 1 are premium customers and we can keep them in complete loyalty program, and for the customer belongs to cluster 0 we can provide them offer or create some strategies for them so that they will do more transaction with us. So this is the conclusion of my project. This project mainly focused on developing customer segments from a UK based online store selling unique all occasion gifts. Using a recency, frequency, and monetary RPM analysis, the customers have been segmented into various clusters and got a velocity score of 0.3942 clusters. By applying different clustering algorithm to our dataset, we get the optimal number of cluster is equal to 2. And the next is the business can focus on these different clusters and provide customer with service of each sector in a different way, which would not only benefit the customer but also business at large. Thank you.